Okay, couple more things with alternating series is that um, with an alternating series, we have something called the remainder. So we can add up a series and then the remaining terms will not be larger. The sum of the remaining terms will not be larger than the next term, the first one that we didn't add, because we're adding and subtracting away terms. So if we think about like the alternating series, n is equal to 1 to the sum from n equals 1 to infinity of the, we'll do the harmonic series, the alternating harmonic series, which would be -1 plus 1/2 minus 1/3 plus 1/4 minus 1/5. Okay, so I'm going to add up these four terms. So calling this S sub 4 because it's a partial sum. So -1 plus 0.5 minus 1/3 plus 1/4 gives me -7/12. And then the remaining part of our sequence here, or our series, is the remainder of the series will not be greater than 1/5 because we are adding and subtracting away. Like I'm going to subtract away 1/6 of 1/5, then I'm going to add a little, or I'm going to add back 1/6, then I'm going to subtract out 1/7, then I'm going to add back. So we're actually adding just like a very small amount of area. So this is what our remainder will not be larger than our next term. Okay. So it says the maximum error is equal to the sum of the series minus the partial series, the sum of the series minus the partial sum, and that's less than or equal to the next term that we didn't use. Okay. All right, so here we go. We're going to get the fourth partial sum, and then we will, to approximate the value of the series, and then we will determine the interval for the actual sum, and then we're going to just say if the partial sum is a overestimate or an underestimate. All right, so to get the partial sum, we kind of just did this. We're going to substitute in n equals 1. So I get -1 to the 1 plus 1. That gives me 2. So that's -1 to the second power times 1 over 1 factorial. And then we have plus -1 to the third power times 1 over 2 factorial plus, oops, that's not a plus, -1 to the fourth power over 1 times 1 over 3 factorial plus -1 to the fifth power times 1 over 4 factorial. And that would be my partial sum. We should put, this is an estimation, so we do need to put an about equal sign. Okay. And then the sixth, that's 1, 2, 3, 4. The fifth term, just for funsies, would be -1 to the 6th times 1 over 5 factorial. Okay, so simplified, that is 1 over 1 factorial minus 1 over 2 factorial plus 1 over 3 factorial minus 1 over 4 factorial, and then plus 1 over 5 factorial plus dot, dot, dot. Okay, our partial sum, we want to add up just the first 4 terms. Okay, so that is equal to 1 over 1 minus 1 over 2 plus 1 over 1 times 2 times 3, which is 6, minus 1 times 2 times 3 times 4, which is 1 over 24. And then I'm just going to write that. And that is equal to 5/8. So the partial sum, S sub 4, is equal to 5/8. Okay. Now, to find the interval, the reasonable interval for the actual sum, we just take the sum, the partial sum, so S sub 4, and we know that it has to be less than or equal to S sub 4, our sum, plus the next term, 1 over 5 factorial, which is 1 over 120, or it has to be greater than the sum minus the next term. Okay, so this is the next term, which for us would be a sub 5 since we were working on a partial sum of 4 terms. Okay, so we just go ahead and solve that. And so I say 5/8 in the middle has to be less than or equal to 5/8 minus 120th, or it has to be greater than or equal to the lower bound and less than or equal to the upper bound, which is 5/8 plus 120. Remember, the next term is the maximum amount of remainder that we can have. So we need to add the remainder or subtract the remainder, and that is going to be our interval of our reasonable interval for our actual sum. Okay, so we get 0.616 bar is less than or equal to the sum. I'm just going to put the sum, which is less than or equal to 0.63. And you know what? This needs to be the sum, the actual sum, not S sub 4. It needs to be the actual sum, okay? So the actual sum is in between S sub 4 plus the error or S sub 4 minus the error, okay? So the last part is S sub 4 an over or an underestimate of the sum? And it is S sub 4 is an underestimate of the sum. And we know this because the last term that we added, a sub 4, is subtracted. So we already took out like more of our value than we're going to add some back. So that subtraction gives us like a little bit less than what we think we are going to have, okay? The value that we think we're going to have. Okay, so we're going to find next is how large does our series, how many terms of our series do I need to add so that the next term or the error is less than or equal to 1/1000th. So what we do is basically what we're saying is that the term a sub n, this term needs to be less than or equal to 1/1000th. So what term is that? Well, we already know how to find the term. So I'm going to say that 1 over, so the absolute value of this, so 1 over 2n minus 1 is less than or equal to, so we'll say the absolute value of a sub n. Okay, so 1 over 2 minus 1 has to be less than or equal to 1 over 1000. And then this one's easy to solve, so I am going to just cross multiply. So 1,000 is less than or equal to 2n minus 1, just like, cross multiply. Okay, and then we get plus 1. So 1001 has to be less than or equal to 2n, divide by 2. So n has to be greater than or equal to 500.5. So that means that the 501st term is less than or equal to 1 over 1001. So that, we should write it like this, that a sub 501 is the first term that will give me an error that is less than or equal to 1 over 1,000. 1,000. Okay, so S sub 500 is how many terms we need to add so that the next term would be an error less than or equal to 1,000. Okay. Okay, we're going to do the next one. So same deal. We have an alternating series. The -1 to the n says that the signs are going to switch back and forth. So we need to take the absolute value of a sub n and make that less than or equal to 1 over 1,000. Okay, so I have 1 over n plus 1 factorial is less than or equal to 1 over 1,000. Okay, I'm just going to expand this because this is not going to take very long for me to get to my error of 1 over 1,000. So for n equals 1, I have, I made a mistake. Yeah, I made a mistake. So this should be a 0 when n equals 0 to infinity, and I'll change it in the notes right now. Okay, n equals 0 to infinity. So for our first term that we're plugging in is n equals 0. So I would have 1 over 1 factorial. The second term would be with an n equal to 1. So 1 over 2 factorial, then 3, so 1 over 3 factorial, plus 1 over 4 factorial, plus 1 over 5 factorial, plus 1 over 6 factorial. And I'm just going to evaluate this as 1 over 1, plus 1 over 2, plus 1 over 6, plus 1 over 24, plus 1 over 120, plus 1 over 720, plus 1 over 7 factorial gives me 1 over 5,040. So I would need to add these first 6 terms in order to get a series, a partial series that has an error less than 1,000. Okay, so one thing to remember though is that this is the series S sub 0, S partial sum of S sub 0, S sub 1. So adding these 3 would give me S sub 2. Adding these first 4 would give me S sub 3, S sub 4, and S sub 5 because we started with n equals 0. So I would have to add up S sub 5 terms to get an error less than 1,000. All right, so the definition of absolute and conditional convergence. So basically, in an alternating series, what we're saying is we know, like for the harmonic series, that it doesn't converge if all the signs are positive. But as soon as we alternate the series, then the series will converge. So if both the alternating series converges and the absolute value of the alternating series, so if then where all the signs are positive, then the series will converge absolutely. It always converges, doesn't matter what the signs are. Okay, if the series itself converges but the absolute value does not, then the series converges conditionally. Okay, so basically this means that the alternating series or series with a series with negative signs, okay, if that converges and the series with all positive signs converges, then it doesn't converge, then it conditionally converges. But if the series has alternating positive negatives and all of it and the series with all positive signs converges, then it's absolutely converging. Let's do 2 examples. Okay, so we have this series that I can tell it alternates because it has the -1 to the n power. So what we want to test is, so this whole thing is called a sub n. Okay, that's the series. It's alternating. So what we want to test is the absolute value of the sum of the absolute value of a sub n. Because if the absolute value converges, then the alternating series will also converge. It's just a limit. It's a direct comparison test, basically. Kind of-ish. Okay, so here we go. We have the, okay, we have the sum as n goes to 1 to infinity of, okay, so the negative is going to become a positive always if it's the absolute, let's just do the absolute value of -1 to the n power over n to the 2/3. Okay, so I get the sum from n equals 1 to infinity of that 1 is going to become positive, and I just have n to the 2/3. What I see is that this is a p series. P is equal to 2/3, which is less than or equal to 1, which is greater than 0. So this series diverges by p series. Okay, now that's fine and dandy. Let's test its original, the one that had positive negative signs. So I'm just going to test as n the sum as n equals 1 to infinity of -1 to the n over n to the 2/3. And I can use, since this is an alternating series, I can go ahead and use the alternating series test, which first tells me if the limit as n approaches infinity of 1 over n to the 2/3 has to equal 0, and it does. So that is a check. The second thing is that the next term, -1 to the n plus 1, sorry, the absolute value 1 over n plus 1 to the 2/3 has to be less than or equal to 1 over n to the 2/3. And that's true because the denominator in the left fraction will be larger, which makes the fraction smaller. Okay, so we know that the second series, when it alternates, converges. So by alternating series test. Okay, so does the series converge conditionally or converge absolutely, or neither, I guess, since this switches signs, does not switch signs. Okay, since a series that switches signs converges, but the series that has all positives doesn't, then the series converges conditionally. Okay, let's do the next one. All right, this one looks cray. Let's see what's going on. So I have -1 to the n squared plus n over 2. All right, that would be -1 to the 1 plus 1 over 2, which is 1, over 3 to the n, plus -1 to the 2 squared plus 2, which is 6, over 2, which is 3, over 3 squared. And I forgot a 1 here. Okay. So then I'm going to add one more term just for funsies, -1. I'm going to substitute 3 for n. So 3 squared is 9, plus 3 gives me 12, over 2, which is 6, all over 3 to the 3 power. Okay, So I can see that we are not switching off our powers even odd. So this is going to be negative 1 over 3 minus 1 over 9 plus 1 over 27. Not alternating. But the signs are switching a little. So we can go ahead and see if the series is going to converge. We still can test to see if the series is going to converge conditionally or if it's going to converge absolutely. So if we take the absolute value of all of these terms, give me the plus. Will this series still converge? Okay, let's see. We're doing it. We're going to test to see if the sum as n equals 1 to infinity of the absolute value of negative 1 to the n squared plus n over 2 over 3 to the n converges. We'll see. So the absolute value of this, that means that the numerator here will always be a positive. So I can just write this as the sum from n equals infinity to n equals 1 to infinity of 1 over 3 to the n. Like, oh, it's so nice. That is 1/3 to the n power. This is a geometric series with a ratio equal to 1/3, which is less than 1. So the series converges by geometric series tests. We should say it's greater than 0. Series test. Okay. Oh, the absolute value of r. All right. So that means that since what we've done here is basically, like I said, put an absolute value around each one of these terms. So when all of the signs are positive for the terms, then the series still converges, which means that when the signs switch, positive and negatives, the series will also converge. So the series, the sum of n is equal to 1 to infinity of negative 1 to the n squared plus n over 2 all over 3 to the n converges absolutely. Okay, that's it.